So now in this topic we are going to study what exactly a compressed Smith chart is. Now all of us know, we have seen in the beginning of the Smith chart topic that Smith chart is basically plotting the reflection coefficient, and reflection coefficient boundaries are from -1 to 1. So in this regard, this center corresponds to the origin of the reflection coefficient plane, and then these are the two are the limits where gamma is equal to -1 and +1 on either side. Then if you have a gamma value which is more than 1, then what it implies? As we have seen in the initial lectures where we are seeing the parametric reflection coefficient, the entire first and the fourth quadrant where r plus or minus jx plane have been transformed into the gamma plane. We have not considered the second and the third quadrant where the impedance or the resistance is negative in nature. Now gamma more than 1 basically accounts for the negative resistance device. Okay, in our practical applications we do have certain devices which actually offers a negative resistance. Now here one should know, negative resistance is not something -10 or -20 ohm resistance is being offered. It is basically the decrement in the value of the resistance with respect to the input parameter. Okay, so that is a different topic altogether. We will not get into the details of what exactly a negative resistance is. We will try to see how to plot negative resistance gamma or reflection coefficient more than 1 on the normal Smith chart what we have, okay, regular Smith chart what we call it as, and how to read the respective Z. Okay, how to read the respective Z. So I have given the problem over here. The gamma is given to you is 1.8 angle -20 degree. This particular reflection coefficient, I want to locate it on my Smith chart, a regular Smith chart, and read the corresponding Z value. So the procedure goes like this. First, the value of gamma is given. What you need to do, just find out what is 1 by gamma. Here you take only mod gamma, not to take a phasor angle over here. Only take mod gamma, so you calculate what is 1 by mod gamma. So it comes out to be, if I just take 1 upon 1.8, it comes out to be 0.555. So the gamma value which I am going to plot over here is 0.555 angle -20. So plot that particular 1 by gamma angle minus theta onto the Smith chart. Now how I do that? First identify the angle theta -20. So look at the angle of reflection coefficient. It is written over here, angle of reflection coefficient. So identify -20 degrees which is written over here, and then draw a straight line towards the center. Then draw a straight line towards center. So you have marked -20 degree axis onto the Smith chart for the corresponding gamma. Next part is we need to identify that magnitude. So for that you go to the bottom third scale where reflection coefficient is mentioned. And mark a point where you read 0.555. You mark a point where you read 0.55. So you can just go down and actually mark a point where you read 0.555. Okay, likewise you can mark that and then take it over here, and then correspondingly you mark that point over here. Okay, correspondingly you mark that point over here. So 0.555 is marked. Okay, 0.555 is marked. So I have plotted the magnitude as well as I have plotted the angle. Next step is read the impedance value. So now I will read the value. How to read it? You just see corresponding touching R circle and X arc. So here if I just read, it is 2.8. Okay, if I just read that 2.8 and the arc is -j1.4. This is the value of Z which I have read from the Smith chart for that particular point. This is the value of Z which I have read from Smith chart that for that particular point. Next step, remember it is a negative resistance Smith chart. So naturally it is not a positive value of R. So once you have read that, just read this value as -2.8 -j1.4. This is the value of Z in for that particular reflection coefficient, which is 1.8. Now you need to cross check this. So what you do, verify this using your equation. Okay, so substitute that your ZL value which you obtained over here into this equation. So minus 2.8 minus 1.4j minus 1. Remember, Z0 should be taken as 1 because I will not denormalize this Zin which I have calculated. So minus 2.8 minus 1.4j minus 1 upon minus 2.8 minus 1.4j plus 1. Calculate, resolve this equation and calculate the polar form of that. You will get the original gamma value back. So the value may slightly differ. You may calculate that to be 1.76, 1.79 like that. So the value may slightly differ. The value may slightly differ. So this is how you are going to cross check it. This is how you are going to cross check it and the value will match. So this is how you calculate, you plot the negative resistance, you plot the value of gamma onto the regular Smith chart and then read the value. So that is the procedure what you are going to follow for plotting a compressed Smith chart. Thank you.